Today, we are going way back to 1972 to dig into a truly foundational paper in artificial intelligence by Roger Schank. It's called Conceptual Dependency, and it was this really radical attempt to get computers to understand language, not just by, parsing words on a page, but by actually grasping the meaning underneath them.
And I love this quote because it really just sets the stage perfectly. You can tell right away that Schank wasn't just trying to build some clever chatbot. No, his ambition was so much bigger. He wanted to model the very structure of human thought to create a theory of understanding first and then build a program based on that theory.
So here's how we're going to break this down. First, we'll look at the problem Schank was trying to solve. Then, we'll dive into his solution, this idea of a universal meaning base and its basic building blocks. We'll see how it works in practice, explore its power to read between the lines, and finally, connect it all to the AI that we see all around us today. All right, let's get right into the core problem. Back in the early 70s, most attempts at natural language understanding were getting stuck in what you might call the syntax trap. They were absolutely obsessed with grammar, but as Schank pointed out, grammar and meaning are not the same thing. Not at all.
Just take a look at these two sentences. John gave a book to Mary. Mary received a book from John. Now, grammatically, they're completely different, right? The subjects, the verbs, the objects, they're all shuffled around. Any program that only analyzes sentence structure would see these as two totally separate events. But you and I know, they describe the exact same thing happening.
And that's the fundamental question, isn't it? How do you teach a machine to see past the surface structure of the words and realize that these different sentences have the exact same underlying meaning? This is where any system based purely on syntax just completely falls apart.
So Schank's answer to this was, well, it was both bold and incredibly elegant. He basically said, let's stop analyzing the surface language. Instead, let's translate everything into a universal representation of meaning, a system that is totally independent of English or Spanish or Chinese or any other specific language.
He called this an interlingual conceptual base. And really the best way to think about it is like a universal language of thought. The idea is that when you or I hear a sentence, our brain translates it into this meaning-based format. And then, when we want to speak, we translate from that meaning base back out into the words of whatever language we're speaking.
Okay, so if you're going to build a whole language of thought, you need a vocabulary, right? You need some building blocks. And this is where Schank's idea gets really, really powerful. He proposed that all meaning, everything, could be constructed from just 4 fundamental types of concepts. Think of them as the absolute basic Lego bricks for any idea.
And this is the part that's just incredible. Schank argued you only need these 4 types of bricks. You've got your picture producers, which are basically nouns, your acts, which are the verbs, and then you have picture aiders and action aiders. Think adjectives and adverbs to describe them. And that's it. His claim was that any idea, no matter how complex, could be built from just these 4 things. So, how do these pieces actually fit together? Well, Schank created this really cool visual way to map it all out using what he called conceptual diagrams. The whole point was to make the meaning crystal clear and completely unambiguous. We're going to use this simple sentence from his paper to see how it works. John hit his little dog. Okay, let's actually map out what's really going on here from a meaning perspective. So you start with the core of the event, John and hit. And see that two-way arrow between them? That shows they are completely dependent on each other. In this concept, you can't have the action of hit without John doing it. And John's role in this whole thing is defined by the fact that he's the one doing the hitting. Okay, but what was hit? The dog. So we connect the dog to the action hit with an object arrow. This shows that the dog's entire role in this little story is to be the thing that was hit. It's not just a word on a page, it's a specific role in the event.
And finally, we just add the details. Little is a property that points to dog, and his links the dog's ownership right back to John. And just like that, boom, you have a complete visual map of the meaning. A map that would look exactly the same no matter what language you use to describe what happened.
Now here's where the real magic happens. This intense focus on meaning allows the system to generalize in a really powerful way. I mean, look at all these different English verbs: give, take, receive, buy, sell. And conceptual dependency, they all collapse into a single, fundamental, primitive act.
So whether you give, take, buy, or sell, the core conceptual event is exactly the same. A-trans, which is just the transfer of possession. And this is the key to solving our original problem. The system now understands that John gave a book and Mary received a book aren't two different events. No, they are just two different ways of saying the exact same thing, a single transaction.
But this framework isn't just about understanding what's explicitly said. It's also about understanding what's implied. It gives a computer the tools it needs for inference, for, reading between the lines, which is so much of human communication.
Now, this gets really fascinating when we look at how the system can handle ambiguity. Let's take this classic example. First line, he went to the man and asked him for a knife. Okay, seems pretty straightforward.
And the man replies, he didn't have one. All right, a simple refusal. No problem so far. But then we get this final line. He said he would get one and kill him. Now, wait a minute. Who is he? Who is him? Now, your brain resolves this instantly, right? You don't get confused. You use context. You understand goals and motivations to fill in all the blanks. But a simple program just analyzing grammar would be completely and utterly lost.
But a conceptual dependency system can actually figure this out. By analyzing the goals and plans of the actors, one person wants an object, the other person denies it, it can infer that the most logical underlying meaning of that final ambiguous sentence is a threat. It actually deciphers the unspoken intent.
So why are we sitting here talking about a paper from 1972? Well, because its core ideas were decades ahead of their time, and they laid the groundwork for so much of the modern AI we use every single day. I mean, Schank's work directly led to concepts like scripts, which is just our default knowledge about situations, like what happens when you go to a restaurant. And the whole idea of structuring the world's information by meaning and relationships, that's the foundation of the knowledge graphs that power search engines today. You can literally draw a straight line from this 1972 paper to how AI understands the world now. The whole focus on what things mean, not just what words are used, it really started right here. So, Schank's theory gave us this powerful tool for representing the meaning of language, but it leaves us with an even bigger question. Because to truly understand, a system needs to know not just about language, but about the world. And that vast, unspoken ocean of common sense knowledge, well, that's the next great frontier.